Phew, nothing grew. You have no idea how happy I was to come in and see that we did not have colonies. I know, normally you want to see colonies because that means that bacteria are growing. But in this case, we have a plate with antibiotics in it. In this case, kanamycin. We wanted to see whether the bacteria that we want to kind of manipulate are resistant to kanamycin. The reason why we really care about this is that we want to do some genetic manipulation where we take out a gene from this strain of bacteria and replace it with the gene for kanamycin resistance. This is going to serve as a selection marker. Basically, it's a way for us to tell whether or not the bacteria actually did that genetic swappage that we wanted them to. It's not that we really just care that they want them to be kanamycin resistant at that point. It's more that we need some sort of way to know whether or not they have the gene knocked out. By knocking it out and putting in the antibiotic selection marker, we're able to do that. We do this genetic swappage, then we grow it in the presence of the antibiotic in order to see whether the swappage occurred. If the swap out occurred, then the bacteria will be able to grow, but if it didn't occur, they won't be able to grow. Assuming that is that the bacteria aren't naturally resistant. And so we wanted to test to see, well, are they resistant already? Because if these bacteria were already resistant to kanamycin, then it wouldn't really give them a leg up in order to give them a kanamycin resistance gene, because they're already resistant. And more importantly, they'd be able to grow in the presence of kanamycin even if they didn't do that genetic swappage. And that genetic swappage, it's going to give them a fitness disadvantage most of the time. So what we want to do is we want to knock out malodehydrogenase, which is this critical enzymatic enzyme, this metabolic enzyme, so that like hub of the citric acid cycle. So it's really important, but at least in Bacillus subtilis, you can knock it out and it'll still grow. Not as happy as the wild type, but it'll grow. And so we want to do the same thing with Bacillus subtilis. Since we've got a bunch of different strains, and we want to see, okay, well, are these resistant to kanamycin? And so one of the ways that we tested is just by plating them on plates that have kanamycin in them. And no, don't worry, the kanamycin is, the bacteria that have kanamycin, like these plates aren't just screwed up. We have our positive control where we have the subtilis bacteria that has the MDH knocked out and kanamycin put it in its place. And you can see here, it's able to grow in the presence of kanamycin, whereas all these other strains of our subfensis are not. And so we're going to be able to use the same strategy that they used in order to knock out malodehydrogenase from this strain. So you can see subtilis here wasn't growing here. But then when you knock out malodehydrogenase and stick in its place kanamycin, you're able to get that growth. And so we want to do the same thing with Bacillus subtilis. And so it's really, really exciting that nothing grew on this plate, because that's telling us that these bacteria are not naturally resistant to kanamycin. And therefore, if we grow them in the presence of kanamycin, after we do that genetic swapping, where we take out malodehydrogenase and stick kanamycin resistance gene in its place, then if bacteria have done that swappage, they'll be able to grow. If they haven't done that swappage, they won't be able to grow. And that then will allow us to know. It's also giving us a way to really, really select, not just to see if they did that swappage, but actually give these bacteria that did the swappage a leg up. Because remember, this is kind of like normally they wouldn't be as happy without malodehydrogenase. So if you didn't have kanamycin around and you just did that swappage and you had some of the portion that underwent the swappage and then some of the cells that didn't undergo the swappage, the ones that did not undergo the swappage, they're going to have a fitness advantage in the absence of kanamycin. So they're going to be like, booyah, booyah, booyah. And then in the process of natural selection, they're going to win out. And so those ones that you actually did the swappage that you wanted them to do, they're going to be killed off. They're going to be outcompeted. And that would be really sad because, well, then we did the swappage for nothing, and then we'd just be growing the same bacteria that did not swap. And so instead, we need to say, okay, well, let's give the other guys a disadvantage. And the way we give the other guys a disadvantage is by adding the antibiotic, that only the ones that did the swappage will be able to survive. And this way, we're able to select for cells that actually underwent that swappage. Well, at least we think that they did. So basically what can happen is that there can be some sort of boo-boo where what happens is they get the kanamycin resistance, but they don't actually do the swappage. I don't know, biology does weird things sometimes. And so then we were going to want to double check. And so we're going to do PCR to basically do colony PCR, take these primers, which will amplify a region that contains the part of the kanamycin gene and part of the thing next to it, and then see whether the bacteria actually contain the region that we wanted them to. And then we can actually go and sequence it, make sure it's all okay. But the first step is just being able to do that selection. And if these bacteria had been able to grow in the presence of kanamycin already, that would not be helpful. So this is really exciting that we didn't see growth. We also didn't see growth in the liquid media, and we're doing some cool diffusion assays to test antibiotic susceptibility to other things. More on that later. But really, really exciting. Probably one of the only times that you want to see lack of growth. So once we do that swappage, we want to see growth, because that'll tell us that we have bacteria that did the swappage, that they swapped out malodehydrogenase and put in the kanamycin resistant gene. But for now, we need to know that our wild type is not going to be able to grow, and this lets us know.